In this video, we're going to discuss implementing a linked list. Now, first what we're going to do is just set up our main program, like so. And maybe let's add our header. Let's add our header so we can meet the course requirements. And, here you'd put your stuff, but, right now I don't know our section number because I'm doing this before the class starts. So anyway, we're going to build a linked list. And first what we're going to do is we're going to look at a concept called test-driven development. Basically what we're going to do is we're going to test our code before we write it. That may sound backwards, but think about it. So let's say we're first going to build a list of integers. So we'll declare a variable of int list and call it list. Okay. And then what we want to be able to do is add items to our list. And list insert at front 1 and 2. Okay, and now what we want to do is print the list for we can use auto here, auto I in list, print out the values of the list. Now, when we go to run this, of course, it's not going to compile. But now we know in order for our test to complete, and let's refactor this and put it in a method called test int list. So we'll say hit void test int list, and here. And so instead of this now, we will say test. And because for a second I forgot I was working in C++ and not a more modern language, we're going to have to move this up here. Or we could put a prototype, but I think this is just less cluttered. So, also, I have a small syntax error here. So anyway, this would be our basic first step in a sample program. So what we're going to do is now come over here and actually create said sample program, or sample library. So, but also use a sample library, we would have to also do our include here, include, int list.h. Okay. Sure I spelled it right. Oh, it's too bad. I was hoping that the editor had a feature to just create it. But anyway, let's create our new item, header file, and we'll call this guy int list.h. Make sure I name this correctly. Also, we should rename this program. This isn't the linked list. This is linked list runner. Okay. And here in our linked list.h file, int list.h file, we would have the definition of our list. But what we're going to do first is in a separate file, we're going to first create our node. And we'll call that guy int node. And the reason I'm saying int node specifically here is because next we will show you how to write a generic node. Anyway, So here we're going to use a struct for the node. Oops. And we will say int data. And we will say int node pointer next. And then we will have a constructor. I'm using a tool that makes life easier for me in my real world work that actually predicts a lot of the things I'm going to do. So we've got our data element and a node pointer. So this gets us started, and it uses default values, so everything gets started on the right foot. So let's also be good citizens, and this structure represents a single node in a linked list of integers. Okay. And because we're using a struct, all the data is public. And therefore, if we were using class, we might want to put getters and setters around it. Anyway, so there is our linked list class. Our node class. Now in the actual list class, what we're going to do is include int node. Okay. And then what we'll do is we'll define our class. Class int list. Right. And here we will have the following methods. We will first have a private method, or a private data value, the head. The head. And as I mentioned, oh man, I'm having problems with that today. And as I mentioned earlier, we might want to keep a pointer to the tail because that makes insertion at the back easier. And so we'll put that here as tail. And then let's put some comments in here. Oops. Documentation. Now, what we're going to do here is we'll create our public methods. Okay, first we'll have our constructor. And that's not going to do anything. We'll just put it here to establish our default. We're just establishing our initial values so they don't get messed up. So, likewise, we'll also have a destructor. And for now, I'm going to set it to the default, but we'll actually have to come back and make this a bit more intelligent. All right, so insert a new front edge at the front of the list. We'll call this method insert in front. Okay. Then we will at the back. And then we will remove the first. Remove the last. And then we will get the count. Be able to check if the list is empty. We don't need that method. Then we're going to insert after. insert. Okay. And then we will have remove, and it will remove the first instance of a value. Okay. Then we're going to have a very important method, clear, which clears a list, but more importantly, we're going to have another method, bool contains, which tells us is that item in the list or not. Okay. So these are some of the basic methods. We can go into more detail as we implement them, but notice here that from the outside world's view, in this public view, you can't really tell anything about how we're implementing it behind the scenes, and we'll take advantage of that later. Okay, so let us make sure we got everything in order. We'll say we're going to if we can't find the value, we're going to throw an exception. Okay. Similarly, whoops, with remove. And, whoops, sorry, I didn't need to do that. List, and finally return true if the list contains a value. Now we're going to actually implement our list. Okay, and we will call this int list CPP, and we'll add it. Then what we're going to do, and I'm a little lazy here, and I will show you how to achieve said laziness, is we're going to implement these methods, but I do not like double typing. So if I'm not going to declare them in the H file, which oftentimes I will, we'll do it like this. Okay. We'll say did I spell it wrong? Okay, so now really quickly, just so I can get myself all set up here, we will we're just putting in default implementation. We'll come back. Okay, we're setting up all this, and we've only got a couple more left to do. guy. All right, so now we got to go in and fill in the blanks. Let's take care of the real easy ones first. First, we'll take care of size, where all we got to reduce. Return is, what do they call it? We call it count. We call it size, didn't we? That we declared in our main program. Is empty is return size equals 0 is one way, but if our count somehow gets out of sync, we will say instead return head equals no pointer, because if there's nothing in the list, there'll be no. All right, so now let us go on and do our inserted front. Okay. First, we declare our new node. Okay. And we set our it to our value. Then what we're going to do is we're going to say we're going to say if head is no pointer, then head equals new null, and we're good to go. Otherwise, we want to point our current node to equals, we have to put our new node to our head, sorry, equals head, and then new node next equals head, and head equals new node. Okay? And just to be clean, we're going to increment our size. I don't think we called it size, did we? Let me double check. I can't recall. Yes, we called it size. I think here I called it count, which is wrong. Oh no, it's size. Okay. All right, so there's the implementation of our basic inserted front. Also, if head equals null pointer, then we're going to want to say tail also equals new node because they're the same value. Now we're going to insert back. We're going to create our new node again. If head equals null, again, we're going to assign them. Otherwise, our current tail's next node equals new node, and tail equals the new node we just created. Okay. Now we want to, if return, not do anything. Otherwise, we're going to grab our first value. Oh, you know what? The type on this guy's wrong. It should return to this. Let me get back over here. And all these removes should shouldn't remove from an empty list. So, in fact, a nicer way we can even say this is if is empty, throw exception, list is empty. Else, Oops, I think I got something wrong here. Oops, sorry. I don't like that very much. Let's just, we'll leave it alone for now. We could throw an error value, but anyway. So, let's change this guy as well. And if this is empty, we're going to do the same thing. Otherwise, we're going to have to find the back item, delete the tail item, and then resize it. Or reset it to the last element. Okay. Then finally, let's see, we have insert it back, we insert front. Let's see, insert after, and we'll say, we're going to create a helper method first. First, if there's nothing in the list. What's wrong with this guy? Oh. If there's nothing in the list, because we're doing an insert after, we're going to throw an exception. And we'll create a new node. We'll say, oops. Okay, so now what we're going to do is we're going to try to find the value on insert after. Current node, and while current node doesn't equal data doesn't equal value to find, and if we hit the null pointer, we're going to throw an exception here. The reason we're throwing exceptions all over is because we don't have a good sentinel value. Anyway, so when we find our current data, it should be in current node. New node next equals this is actually backwards, insert after the value. We're going to say current node next equals new node. And okay, actually, first we got to say new node next equals current node. So next, and then current node sub next equals new node. Now, what if the case is if it's the last node? Well, then new node sub next equals current node dot next, and next is no, and that'll be no, and then current node dot next equals new node, and boom, we're inserted. Okay. Now here, oops. Current node equals head. We follow through to find the first instance. We keep a back pointer backtracking so that way we know the node behind it. And if it's the head, we just skip the next. And if it is the not the head, we just move along and skip to the next node. Okay? For clear, we're going to run through and grab the current node, move it to the next current node, the next one, delete the temp, and set everything back to 0. And contains is actually something we've already done above. And the first time we find our match, return, otherwise we return false. Now that we've implemented this, let's go see if we have everything we need. We don't have an iterator established, so we are instead, we can't do that over list, sorry, so we'll do, let's see. Oops, it's actually right here. This should be get head because come over here to list, we do have to add a get head. And while we're at it, we might as well do a get tail. All right. And we'll call this guy current. Data, and then we got to move to next. Okay. Is empty. Oh. All right. Okay, this has nothing to do with the runnability of our code. And a vagary of the C++ Visual Studio System. So if we run it, we should see. Actually, it came and went so fast that we don't see. And we see what we expect, 2 and then 1. So this is the introduction to creating a very basic integer-only linked list. In the next video, we're going to talk about how to modify this into a more sophisticated generic linked list.